Right, last question. Sorry, not last question. Second last question. The electric motor of an 875-gram model train accelerates the train uniformly from stationary to 0.620 meter per second in 21 milliseconds. So we have to find the average power delivered to the model train during its acceleration, and lastly the instantaneous power at t equal to 5 milliseconds. Okay, so the difference between average power and instantaneous power is, for average power, they will be giving you a certain period of time. Tapi untuk instantaneous power, the question will only give you one time saja. Okay, so that is why it is called instant, at that instant. Time tu berapa speed dia, ataupun berapa the power, instantaneous power. Macam tu lah. Okay, tapi kiranya dia punya time ada satu saja. Kalau average ni, kita ada delta. Macam tu. Okay? Alright, so now, the average power is equal to the change in energy, the change of energy over the change of time. Rate of change of energy. Macam tu lah. Okay, so energy ni apa pula? So energy ni, change of energy is what? It is work done. Remember, work done is the change in energy. Okay, so what energy are we talking about here? We are talking about kinetic energy lah. We are using work kinetic energy theorem. Okay, so we can write down delta K over delta T di sini. Okay, so what is delta K? Delta K is half mv square minus half begitu. Cepat. So that is half m v minus u square. Okay, so over t final minus t initial. Okay, so sekarang ni kita tahu u is equal to 0 because it starts from stationary. So time pun should be equal to 0 lah untuk initial dia. Okay, so from here we can just substitute the values. This is square divided by the time, which is 21 milli kan dia bagi tadi. Okay, so the average power is then equal to 8.01 watt. Okay, so that is very straightforward, and the formula is given in your a formula sheet. Okay, next we have to calculate the instantaneous power. Okay, so for instantaneous power, that is when we use F times dengan velocity. Okay, times dengan velocity. Okay, so untuk force yang ni, force dia ni mesti force yang constant. Okay, so the force is constant, baru kita boleh guna this formula. Okay, so first we have to calculate the value of force. Sebab kita tiada nilai force, kita just ada the speed. So how do we calculate the value of force? Is we know that force is equal to mass times acceleration. Tapi sekarang ni the problem is we do not know the value of acceleration. Okay, so macam mana kita cari acceleration? Remember, acceleration is the rate of change of apa itu? Delta V over delta T. Okay, so delta V is our speed, which is, where is it? 0.62 minus 0 over 21 minus 0. Okay, so acceleration tu kita dapatlah 29.52 meter per second square. Okay, so after dapat acceleration, kita perlu cari nilai V. Okay, kenapa kita perlu cari nilai V? Sebab sekarang ni kita perlu cari V juga di sini. Okay, and F. So dapat nilai acceleration, we can find the value of force. Tapi sekarang ni kita perlu nilai V pula. So kita bolehlah apply our chapter 2, which is V equal to U plus AT. Okay, so carilah U dia berapa tadi? Kita tahu U is 0 because it starts from stationary. Plus dengan the acceleration that we've calculated just now, and then time ni kita guna berapa? 5 atau 21? Kenapa kita mau guna 5? Sebab sekarang ni dia tanya at t equal to 5 milliseconds. So that's why we are going to use 5 milliseconds. Okay, so jawapan dia 0.148 meter per second. So, boleh lah calculate the instantaneous power. Kamu akan dapat mass is berapa so tadi? 0.875 times dengan the acceleration, which is 29.52 times dengan the velocity. Okay, so dapatlah instantaneous power there to be equal to 3.82 watt. Okay, so please remember the velocity that you are calculating is for 5 milliseconds. Kalau kamu guna 21 milliseconds, kamu akan dapat jawapan yang salah because dia minta t equal to 5 milliseconds. Right, so that is on power, and that is the solution for question number 10.